In this video, I'm going to be talking about refracting telescopes. In 1608, Hans Lippershey invented the first refracting telescope. In 1609, Galileo was the first person to use a telescope to observe the skies. Galileo discovered the rings of Saturn and was the first person to see the four major moons of Jupiter in 1610 using his Galilean telescope. It used a convex objective lens and a concave eyepiece lens and could magnify objects 3 times. Telescopes he made later magnified objects up to 30 times. Isaac Newton improved the design of refracting telescope using an objective mirror instead of a lens. Now it's called the Newtonian telescope. The speed of light, c, equals 3 times 10 to the 8th meters per second when in a vacuum and in a straight line. When traveling from one medium to another, some light will be reflected at the surface of the new medium. The higher the refractive index, the more it slows down the speed of light. Additionally, light bends towards the normal when traveling in a medium with a higher index of refraction, and away from the normal when traveling in a medium with a lower index of refraction. Refracting telescopes focus light and make distant objects appear brighter, clearer, and magnified. Most refracting telescopes use 2 main lenses. The largest lens is called the objective lens, and the smaller lens used for viewing is called the eyepiece lens. Lenses form images by refraction and are typically made of either glass or plastic. If a lens is convex, it takes parallel light rays from a distant object and bends them so that they converge to a single point, called the focal point. If a lens is concave, it takes parallel rays and bends them so that they are spread out. The rays then will appear to originate from a point in front of the lens. This point is also called the focal point. Now to talk about magnification. The size of an image produced by a lens is proportional to the focal length of the lens. The longer the focal length, the larger the image. The magnifying power of a telescope is the ratio of an object's angular diameter to its naked eye diameter. This depends on the focal length of both lenses.